Nepal. Wow.
Yeah.
Okay.
Okay. Well,
Okay.
good evening. It is evening here in Sydney, and good morning to
Yeah,
you.
no. Good morning, European
Hello, hello,
audience.
Marco. It's we finally meet. It is so nice
Yeah, yeah, yeah,
to see you. Not
yeah.
in person. I was hoping that we would get a chance
Yeah,
in
I
person,
know,
but
I know.
this is the very next best thing. So, hello, everybody. Welcome. My name is Danielle Stein Fairhurst. I am a financial modeling specialist based here in Sydney, Australia, and I am always on the lookout for some really interesting topics that are interesting for financial modelers. And I was so excited when I heard that the one and only, the famous Marco Russo was coming to Sydney and Melbourne, which was super exciting. And he agreed to run a live hybrid event for us in Sydney. Unfortunately, we had to postpone it, but we are going ahead with the session, and this is it. So I haven't had a chance to ask you about your trip to Australia, Marco. How did it go?
Oh, it was good. It was a blast because I went to New Zealand and Australia, and all in 3 weeks I delivered 3 classes. I didn't have much time to, let's say, visit anything, but actually I visited Australia so many times. So this
So it
time it
wasn't
was
your
just
first.
work, and I met some friend, of course. But yeah,
Oh, fantastic. Oh, I'm so glad you got to come out here.
yeah,
So you are going to talk to us today about budget modeling in DAX.
yes,
And yeah, and yeah, so I won't introduce you. I'll let you do that. You are a Microsoft MVP and you've written tons and
yeah,
tons of books and courses and things like that. So I will, without further ado, let you share your screen and do jump in
yes.
with any questions or comments. There is a Q&A section down the bottom if you're joining us live, or just pop your question in the chat. We have a lot of people on live, and we will hopefully get time to address all of your questions.
Perfect. Okay, so my name is Marco Russo. I work at Siebel BI. Today we would talk about budgeting. The focus of the session is to explain options in terms of data modeling and in terms of DAX code. I expect the audience to have very different skills about DAX and data modeling. So the goal is to show what you can do rather than explain in detail how to do that. Of course, I will show and I will answer questions. And I will provide you also a link to uh, an article that describe this problem in more detail. And so you can also download their another sample file. I think that Daniel will provide the slides and the demo of the demo files I will show you today. But besides, there is also an article explaining this in more detail if you want.
Yeah, I just shared
So,
in the chat.
okay, perfect. Yes. So let me move the chat window here so I have in another monitor I can see that. Okay, good. So just 20 seconds of advertising. I work at SQL BI with Alberto Ferrari. We produce content about DAX and data modeling. We have many courses from introducing DAX and data modeling, which are free, and to more advanced courses, video courses, and we also deliver class in person all around the world. Today, I think Alberto is in Canada, in Calgary, and then in Vancouver. So we alternate every other week we fly somewhere and we deliver in-person classes, but you can also watch the pre-recorded videos that are available on our website. That's it. So let's move forward and let's talk about what we're going to see today. So just Daniela, sorry, one question. The bar that I see here for the bar here for Zoom is something that you see, or you see the entire because I
No,
see on the top a big okay that
no, we can
just to know.
only see your slides.
Okay, because I have no idea how to remove. Oh, okay, now I
Don't
totally
worry, yeah,
understand. Okay,
just
good.
ignore it.
Okay, I don't use chat Zoom often because I usually Microsoft has Teams. So okay, so let me give you a couple of words about what we're going to do. So the idea is what happens if we have a model with data. In this example, we have the classic, and I'm going to show you what we have in the model. So we've had the classic sales data of Contoso. So ignore the part on the right. So just the focus on this part. So basically what we have is a model where we have sales, right? Sales by customer, by date, by product, and there could be many other tables in the model. But basically what we have is something that could be data about sales, data about purchases, data about consumption, any kind of data that has different, we call them dimensions, different attributes, different properties that we can use to group data and to, slice and dice the information. Now, what happens when we have the system working, but then we want to compare this data with something that comes from another data source that could also have a different, what we call a different granularity. What does it mean? If we look at this data, and I go straight to the table that contains the transaction, just because I want to explain what I mean when by granularity. The table says that you see here, this is the table says. The table says has just, in this case, just 5 columns. It could be much more, but conceptually, what I want to focus is that for each transaction, right? So for each transaction, which is each line in each invoice, we have a line, we have a row in this table. And each row has a product, customer, a date, quantity, and price. Very simple. But conceptually, when I say the granularity, I mean, okay, the level of detail of this table is each transaction in the system, each line in each invoice, in each order, in each purchase order, whatever is the information that you analyze. So this is the maximum level of detail, and we call this granularity. Now, when you have this data, the transaction data, usually you have the maximum level of detail that allows you to do any kind of analysis, any kind of grouping. But when you define a budget, is the typical case where you want to compare this information, the sales, with another information that comes from another data source with a different granularity, with a different level of detail. In this example, you can see that we have the transaction by unique product, unique customer, and unique date. But when I look at the file in Excel that I want to import in my model, this is the Excel file that I have defined with the budget. Now, the budget has, let's say, 3 different scenarios, right? So we have we define 3 budgets, actually, not just one, 3 budgets. So for each scenario, we have a number which represents the sum of the sales for a given group of customers and group of products. Now, what does it mean? One line here represents a group of transactions, all the transactions for all the customers in China and all the products that have this brand. Now, this is a different granularity because the level of detail of this table is at a much more aggregated level compared to the other one. And here is the starting point. So what happens when we have 2 different set of data, 2 different files, 2 different Excel files, or 2 different data sources that do not match the level of granularity of the data, and we want to do the comparison. This is the entire problem we want to analyze. The budget is just one of the many examples that we could have for this typical scenario. And of course, the budget by itself is a problem that probably who is in accounting faces often. But as I said, the same problem could happen in many other scenarios. Also, when you have, for example, data coming from 2 different systems in the same company, and they don't match the level of the granularity. Same problem. Okay, same tools that we can use to solve this problem. Okay, this is just to define the problem we want to solve. Any questions so far? Just to make sure. Okay.
No,
so,
we're good. All good. That makes perfect sense.
Perfect. So, what does it mean? So when I go back to the slides for a moment, then I will use the slides mainly as a recap. What happens is that we have several tables that existed in the model since the beginning, which are these tables here. This part at the left side of the model is what we had at the beginning. And I will come back on this in a moment. And then we have a new table that at the moment doesn't have any relationship with the other tables. Why doesn't have any relationship? Because the granularity is different. Let me go deeper on that. And in order to do that, I want to go to Power BI. So you see that I moved this out, but now this is the Excel file I imported. So I don't just show, Excel workbook import, and we import the file. Okay, there could be many techniques. It could be another table in another database. It doesn't matter. But once we include this table, the budget table, in the model, what we see is the following. When we consider, for example, the customer table, if you remember, in the sales table, we had just a column, customer key, that identified the customer. But actually, each customer has a name, an occupation. The customer lives in a city, which is in a country, which is in a continent. So the attributes that describe the customer are typically in a separate table. Once again, what is the cardinality of this table? What is the level of detail of the table customer? Well, the level of detail of the table customer is the column that defines this one-to-many relationship. So each customer in this particular case is identified by a customer key. So the customer key is the unique column that is that must be unique for the entire table. You cannot have two customers with two rows in this table with the same customer key. So there should be one row for each customer. Same for the product, same for the date. This we call this field a unique column, right? It has to be unique. Every row has to have a unique value compared to the other. And we say that the cardinality of the customer is the customer key, right? So the table customer has a cardinality where each row represents one customer. What does it mean? When I consider a country, for example, here, there is a country region. There are hopefully many customers in the same country, right? So the country is an attribute that is used to group customers by that country name. What is the result of that? If we look at the report and ignore for a moment the second column, just look at the first column here. So let me hide this one for a moment. The sales column here shows, this is brand, but it's the same thing. So let's replace, let me duplicate this page. So I show this by using the customer country as instead of the brand. So what we see is that for each country, what we see here is the sum of the transactions of all the customers that are in that country. This is what we have, right? So, and when we look at the data by country, this is what we see. If I go back to the initial report, you see that instead of using the country or the customer, I'm using the brand. But the concept is the same. If I go back to my model, we are using, let's go here. We're using the product brand column, but actually the relationship that connects product to sales is using product key, because product key is the cardinality of the product, right? So this is the situation we have so far. Now, in the report, we're not using product key, we're using brand. And if you think about that, well, if I use the brand of the product and I want to compare the budget that I have by brand, if you remember, our budget table is an Excel file that has the country, the brand, and the number that represent the budget for that particular combination of country and brand. Well, but wait a minute. If I have a brand and I want to create this report, right? For a given brand, for example, Contoso, I would like to see compared to this number, which is the sales of all the transactions for the products of this brand, I would like to compare the value I have in Excel that has that brand. And if you go to Excel, this is easy, right? So you go here, you say, oh, Marco, but I just want to do this, right? I want to do this. I want to get the number that, for example, for this scenario medium, I want to get the sum of these three cells, because if I want to get the brand, I just ignore the country. I just want to group by brand, right? That's the idea. Now, the data model that we have, and let me go back to Power BI. At the data model level, the cardinality of the tables involved doesn't match. But at the report level, we want to create a report where the cardinality of the report is compatible. We want to group the sales by brand, and we want to group the budget by brand, and we know that this comparison makes sense. We know that, right? Well, I mean, okay, how can we solve this problem? Because if you look at the model now, what is happening is the following. I imported the table. I'm selecting medium because the scenario, I'm filtering only the medium, the value for the medium budget that you have seen in Excel. And what you see here is what? What we have at the moment, you see that there is this budget column in the report, but this budget column is actually just the column budget. I didn't write any DAX code so far. I just imported a table and I put this number into the report, and I'm doing what? When you see this symbol here, we are doing a sum of the column. So you see that here, we're doing the sum. We're doing the sum of the column budget. But this sum is summing every brand. Why? Because if you think about this, what we have here is the budget. Sorry, not the budget. What we have here is the brand from the product table. And this is the column brand we applied here. So what is happening is that from a data modeling standpoint, we are filtering this column brand, but this column brand is not filtering the table budget because there are no relationships so far, right? This is what is happening. Now, this is what we had in the slide. So the slide shows that there is a logical relationship, a logical connection between country, region in budget and customer, and between brand in product and budget. It is just that this relationship, we know that this relationship exists in the data, but at the moment, this relationship is not described in the data model. And the question is, okay, what can we do? We want to use it, right? So what can we do? Okay, so at this point, we have several solutions. Conceptually, we would like to create a sort of relationship, but I want to explore the different solutions to the problem because actually just creating the relationship without understanding what is happening could be dangerous. We have to understand what it does mean to create that relationship and what are the things that we can do and we cannot do, because otherwise we get bad numbers. We don't want to get bad numbers. So let's start with the simple solution, which is the following. Instead of creating a relationship, I can just use the DAX code. What does it mean? Well, I could create a measure. And as I said, my goal is to show you what we can do without spending too much time because we don't have hours. So I have to give you several ideas about the possible approaches to this problem. And so my first solution is that, okay, let's create a measure, budget amount, which at the beginning just sum the budget column. Okay, this is technically, so far, I created a measure that will just show the same number that we have now in the column budget with maybe the decimal points. Okay, so at the moment it's the same number. But now, because I created a measure, I'm in control. I can do something more than just showing the number as a sum. So I just create some space so I can write something. And the first thing that I can do is, well, when you use Power BI and you use the DAX language, you can intercept any calculation in any cell of the report, and you can decide to hijack the calculation as you want. What does it mean? I can write a formula that says, well, I know that the user could filter the product brand. I want to get the brand filtered in a specific cell, and I want to filter the budget table with the same brand. How can I do that? Well, there are several techniques, but basically the calculate function can modify the calculation, changing the filter applied to a table. For example, I could say, well, the budget brand should be should be a brand name included in the values filtered in the product brand column. Okay.
Kind of like a filter function in Excel, isn't it? So it's similar.
Well, the Excel would be different. So we don't have exactly the same function, but conceptually is a sort of, oh, it's like we are doing a sort of sum if you want, or something like that. it could be something similar, but the syntax, so the concept behind this approach are a little bit different, but conceptually we're saying, I want to compute this calculation, but I want to apply a filter, because if I don't apply a filter, what we have seen, I always see the same number. You see, I always see 39 million, which is the sum of all the medium scenario budget. So this is not helpful. So if I filter the brand, and because remember, we have the brand, we have also the country. So I have to repeat this for the budget country region, which has to be in the values of the country region of the customer. Okay. So if I create these two filters, so these two lines are, let's say, propagating the filter from the product and customer table to the budget table using those two columns. So I didn't create a relationship in the model, but in DAX, I can filter the table trying to understand what is happening in the report. Now, remember, what I'm writing is a formula that will be evaluated for every cell of the report. Okay, so if I click enter now, what I see is that I see the budget filtered by the corresponding brand. I mean, good, right? We'll say what is the problem. Well, let's say that this way of approaching the problem works, but is not ideal from, let's say, a performance point of view, because you have to repeat this set of filters every single time you create a new measure. So if you have, now we are doing just a budget and we have only one metric, but imagine you have multiple measures. So then you repeat this operation multiple times. And from a performance standpoint, it could be not ideal. For this small model, it's fine. But in case we had, I would say, tens of thousands of brands, tens of thousands of countries, which is actually not the case, but in another model it could be, then this idea is not the best practice, I would say. Okay, so it still works, but
because you'd have to build it and it would take a long time, or it would take a long time to calculate.
No, to the execution of the report, the processing time would be the same. It's just because we are creating a measure, the measure impacts only the execution time when you run the report. So there is no impact on the refresh time. Okay, so the refresh time is not impacted. We're not creating additional infrastructure to this. Okay, so this is a technique and it works. Now this works. Let me show you an alternative to that. So this works, but in DAX, there is a technique to obtain the same result, which is using another function, which is called treatise. It's very similar. Treatise is actually more flexible. I can write treatise saying, well, I want to get the values in brand, and I want to use this list of brands, which are the brands selected in a single cell or in a, for example, the total has all the brands. So the total has the list of all the brands. And I want to apply this as a filter to budget brand. So it's actually the same. So conceptually, we're doing the same thing of this line, no differences. Treatise is a little bit faster than this technique. So nowadays, and I'm showing you this just because it's something that is, I would say, more modern in DAX. You might encounter examples using this technique. So don't be surprised. You can rewrite the code using in values if it helps you. It's the same. It's just a little bit faster. That's it. But conceptually, we're doing the same thing. There are no differences at all between these two approaches. Okay? And the result is the same. No differences. However, if I use this technique, I still have the problem that I have to repeat this code in every measure, which is not ideal. So the question is there a way to obtain the same result by using the model? Well, yes, but the reason why at the beginning we cannot use a one-to-many relationship is because we have a situation where the two tables are not cannot be connected with a one-to-many relationship. Let me explain why I want to use this relationship. Whenever you can, you should use a one-to-many relationship because it's the more efficient relationship and also the one that doesn't provide negative side effects to the model. When we will use a different relationship, but I want to show you that actually I don't have to. So I have a solution like, I mean, we can solve the problem in DAX. Not ideal, but it works. I'm going to show the problem solved in the data model in two different ways. And they will be equivalent. We will certainly use the last one at the end, but the intermediate one explains better what is happening inside, and is also what I need to do to explain you the real problem, which is okay, when I cannot use this, right? Which is the more important thing. So let's move forward. So if I cannot create a one-to-many relationship, why I cannot? In order to create a one-to-many relationship, I have to connect a column that is unique in the table on the one side. And now I have a problem because the brand, sorry, let's go here. The brand is the only column that, let's say, conceptually connects these two tables, product and brand. But brand is not unique in product, it is not unique in budget, which means that I cannot solve the problem this way. However, what if I had a table with a list of brands? You say, Marco, we don't have a table with a list of brands. Well, I can create it. I can create a table brands. A calculate table is the ability to add a table to the model using a DAX expression. And for example, the list of the brands could be just the list of the unique values of the product brand, okay? If I create this table, now I have a table that I can connect between budget brand and one-to-many and product brand, okay? And I can do the same for the country, but I will do this in a moment.
I love it. I love it.
Okay.
I know you could do that.
Yeah, but let's move forward. So at this point, okay, wait a minute. So what happens now? If I go back to my report, you see that my report still doesn't work. Let me remove in my report. I use this technique with DAX. So let's remove these two solutions. Okay, let's remove these two solutions. Now I'm back to the measure that doesn't do anything, just the sum. It doesn't work, right? So just because I created the relation, it doesn't work. But why? Because now in the report here, sorry, let's see if I can show this. Here we go. Okay, you see that when I move the mouse here, you see product brand. The column I'm using in this area of the report is the product brand. If instead of using the product brand, I use the brand column, then brand in the brands table filters product and sales and filters budget. And so not only my measure is working, but also the original implicit measure is working. So basically, I'm using a solution now that works even though I don't use DAX. And this solution, by the way, has also another advantage. Think about the problem. What happens if in the budget we have a brand that doesn't exist in any product? Because you have a new brand next year, and this budget, this brand is new. So if you think about the problem, in the previous example, when I use the product brand from the product table, well, that brand doesn't exist. But the brand doesn't exist here too. Well, but yes, not yet, because I can rewrite this code saying, well, you know what? I want to get a list of brands with by combining both the product brand and the budget brand. And then I remove the duplicated values, which is the distinct that you see here. So this technique says, give me the list of brands from the product table, give me the list of brands from the budget table, combine them together. Now, at that point, I would have duplicated values, but distinct here, remove the duplicated values. So at this point, in this case, it doesn't change anything, but this is the only solution that works by combining brands of different tables. So actually, if you think about what I'm doing, I'm not importing new data from the model. I'm just adding a table in the model that is obtained by combining data that I already have in other parts of the model, in other tables that I already imported. And this table has the only purpose to make it easy for the user to navigate the model without writing any DAX code. That's the idea. This is the only solution that we will see that actually can show brands in the budget that don't exist in the product. Unfortunately, moving forward, I will lose this ability because usually what happens at this point is that If you create a model, so if you create the model for yourself only, you can live with that probably. I don't know. But if you show this model to a customer, to a user, to a business user that doesn't know all the details about granularity and all this stuff, that user would say, Marco, why do we have 3 brands here? We can say, okay, wait a minute. We could hide the brand column in the budget. We could hide the brand column in the product so that the user will only find the brand column in the brands table. That's a possible approach. But if you think for a moment, we would like to have all the attributes of a business entity in the same folder, which in Power BI means in the same table. If I have a brand of the product, I expect that column to be part of the product business entity. I don't like to call this table. From the user point of view, this is a collection of attributes for that business entity. And I would like to see everything about the product there. Also because this way I could create hierarchies. Like, for example, in the date table, I have year, month, and day, year, quarter, and month. So I would like to have, I don't know, brand and manufacturer and color, because this is a typical hierarchy I want to include in my report, for example. Well, if you include columns in different tables, you cannot. So that's the reason why, even though this approach works well and doesn't require any DAX code, in reality is not our, let's say, primary solution to the problem. So we would like to, let's say, show to the user only this brand, hiding this and hiding this. If we really have to create this table, we want to hide it. So in other words, I want to go back to the report where I use the brand column from the product table here. But now my code is not working again. But at this point, there is a difference. Because at the beginning, I didn't have a way to propagate the filter. Now I have one, because I have relationships. And at the moment, when I filter the product doesn't filter the brand, because the filter propagation of this relationship is one to many. But I can do something here to change things. Before doing that, let me create also the table countries that does the same for the customer, because we want to create a complete model. So I create a table countries, which is equal to distinct of union of distinct of the country region from the customer and distinct of the country region of the budget. Now I have the table. I can combine this table here, and I connect this one here and this one here, just to show a complete solution. Okay. Now,
Marco, can I just ask before you move on?
Yes.
We just had a question from Mike Thomas when you first created that brands table about whether that will affect performance just because it's making the model larger, or does it not make much difference?
The question is legit. All the calculated tables that I create are, let's say, refreshed whenever you import the model. And every time you refresh the model, you refresh the other tables, these tables are refreshed too. And yes, they consume memory, but these columns, so these tables have only one column and only the list of the unique values that you have in columns that hopefully are not, let's say, too large. I don't expect to have 1 million brands. I expect to have 20 brands, 100, 1,000. Usually the tables that are expensive are tables like sales, maybe like budget, but just the list of unique brands, the list of unique countries, it shouldn't be so expensive. And so it's a sort of trade-off. Yes, there is a cost for that, but actually, usually it's a small cost. I don't like to create too many of these tables, but in this case, there is also another advantage in using the calculated table instead of, oh, Marco, there is another question I receive often. Should I import this table in Power Query? Yes, you can. But actually, we will see that we could get rid of this table in a moment. But let's say if you want to use this approach and you want to import the table in Power Query, you can. But the advantage of having a calculate table here is that it is guaranteed to be let's say, aligned to the other tables. I mean, in Power BI, you can refresh a single table. So if you refresh only one table, for example, the budget, and you don't refresh brands, you might have the two tables that are not aligned. The calculate table guarantees that it is always aligned. It's Power BI responsibility to always refresh the calculate table whenever something changes in the other table. So I don't have to worry about the consistency of the model with the calculate table. So from my point of view, this is one of those few cases where a calculate column or a calculate table makes sense. It is faster than getting the data from Power Query. It is not using any new data. So I'm just using this like it was an index in the model, and it is guaranteed to be consistent. And usually it has a low number of unique values, which means that it will not have a big cost in memory. Okay, there is a cost in memory. I'm not saying no, but it usually is something that compared to the rest of the model is usually a small fraction, and I can afford it. Okay,
that makes perfect sense. Thank you.
Okay, so now let me go 1 second to the slide. So I want to check that I didn't forget anything so far. So this is a description of the problem. These are the slides that you will see. We have seen that we can propagate the filter by using DAX. We're using treatise. We have seen that we can propagate the filter by using in values, which is easier. Treatise is a little bit faster. DAX is not ideal for the performances for this job. And so we came up to this different definition of the problem where we defined the tables, country, regions, and brands that create the right granularity. Because now we have the granularity to connect the budget with the one-to-many relationship. Problem is that we don't like the user to use brand and country from these additional tables. So we would like to hide these tables. But if we hide this table, how can we enable the user to obtain the right number? So let me go forward here. Well, the idea is that we have the ability in Power BI to create a bidirectional relationship. Okay, so here and here, right? So let me explain. Let me go back to the model. You see that when I see this relationship, if I filter the product brand, if I convince Power BI to filter the row in brands, in the brands table, according to the selection I made in product, then this filter will automatically propagate to budget as a consequence, and this will work. However, you say, Marco, but I read on the internet, don't use bidirectional filters because of ambiguity and blah, blah, blah. Yes, but in this case, this is a smart thing to do. So the bidirectional filter in this case is this. And let me try to explain. When I zoom, you can see the zoom, right? Now in zoom, okay. At this level of detail, so if I look so close these two tables, what I see is a bidirectional filter between product and brands. Okay, this is what I see at this level. But when I zoom out, what I see is that if I filter product, I filter budget. If I filter budget, I don't filter product. Ignore for a moment what we're doing here, right? The bidirectional filter exists only for that table, that brands table, but it doesn't have, it doesn't introduce any ambiguity in the model. The reason why we say don't use bidirectional filter is because bidirectional filter introduces an ambiguity in the model. But in this particular case, we created a bidirectional filter just to create a single direction filter between product and budget. The combination of relationship, table relationship, bidirectional, single directional, many one, one many, using a pattern, a data modeling pattern to obtain a behavior that is actually this, a logical relationship that connects these two tables with a single direction filter. Okay, this is what we're doing. But this relationship is working at a different granularity. The relationship between product and budget filters the budget by brand. Makes sense? This is important because in a moment we will see what is the, let's say, side effect of that, because there is a price to pay for that. It's not free, right? Okay, so this is why. So this bidirectional filter is fine and doesn't create any side effect. And if I go back to my report, both the original implicit measure and my measure that now is just a calculate, they're both working at the moment, which is nice. Now, so from the point of view of the end user, let's say that the end user should not see this. I want to hide this table. I want to hide the countries table. So basically what happens is that the user should never see the brand in two different places. Let's remove this and let's remove this. If I search for brand, I expect the user to find only product brand. So they will use product brand, it just works. As long as we use the brand in the report, which is the problem we had at the beginning, right? Now, two things. So this solution works, but there are a few limitations. Before looking at the limitations, let's see what we can do in Power BI to avoid doing this job. If you think about what I did, I had to, 1, create a calculated table, 2, create 2 relationships, 3, modify the filter direction, okay? But internally, this is what I'm doing. I created this artifact to enable the propagation of the filter from customer to budget without writing DAX code. This is what I did at the end. Now, I can get rid of this, and I can just connect country region to country region. Now, pay attention at what happens, because at this point, Power BI will show something that in part is correct, in part is not. I want you to understand what is the part that is not correct. So when I create this relationship, the relationship that is proposed is a many-to-many cardinality relationship. I cancel this. I will go back later on this. But look at that. If I go here, if I look at the relationship that is still active, we are creating a many-to-many relationship connecting these two tables. This is what we're doing. So it's the same thing. Many-to-many is a many-to-many cardinality, because the cardinality of the two tables we connect is on the many side. We don't have a one side. The one side is hidden, okay? But remember, what we obtained at a high level is a single direction filter. So we want to filter product filters budget, not the other way around. If you look at what we obtain with this path, product filters budget, but if I filter budget, budget doesn't filter product. This is what we want. Now let's go back to what Power BI does. If I connect country region, it identifies the two tables, it identifies the cardinality, it doesn't identify the cross filter direction. This is deadly wrong. This is wrong. You don't want to do this. What you want to do is to do exactly what we did in our model. Customer filters budget single, not the other way around, because otherwise we would introduce ambiguity in the model, which is what we want to avoid, okay? So when you use this technique, you have to select the right cross-filter direction. And if I click Save, what you see now is this. You see this relationship is a, let's see if I can, I wanted to show on the other side. Come on. Okay, let's keep this way. It's a many-to-many single direction. What is the meaning of this? Well, the meaning of this is that this is a limited relationship that will not show the blank row in case there is, let's say, a budget country that doesn't exist as a country in the customer table, right? So this, let's say, gap in the relationship identifies a limited relationship that doesn't show the blank row to aggregate all the values on the many side that don't have a matching value on the one side. You lose this ability, like we lose this ability also in the other case, because remember, the only case where we can see the blank row, we can see all the values coming from the two tables, is when we have this table and we filter the brand column in this table. If we filter the brand column in the product table, we can only see the brand that exists in product. But if a brand exists in budget and doesn't exist in product, we cannot see that. If you want to fix that, you have to fix the product table. I don't have another solution. Now, can we use this technique also for a product budget? Yes, the behavior of these two techniques is the same. But I wanted to show you how, let's say, internally, what is the internal correspondence of these two techniques, because they are equivalent in terms of feature, in terms of functionality, but it's important that you understand that you should always use here a single direction in case you use this cardinality. Okay, that's the important thing. Which one is better? Hard question. Let's say that we will use this technique, which is simpler, right? It's just you create an error. You don't. I mean, it's easier to use. Most of the times, there could be cases where the other technique I showed you before is faster. It's hard to predict when the two are different, but it only matters when you have a number of unique values in this column, in the column that connects these two tables, with thousands or more. Don't even test, don't even benchmark it if you have, I don't know, 100 or less, or just a 1,000 value, doesn't matter. If you have 10,000 unique values or more in this relationship, then you might want to try both and see whether there is a difference in performance in the reports that you will use. Because remember, the difference could be significant in a few reports. So it's not only that one is faster, it depends also on the report that you create. So in case you have a reporting issue, a performance issue, you may try both, but don't try to over-optimize in advance. Try to use the other approach only if you detect that there is a performance issue. Because of course, this relationship is slower than the relationship like this one, right? A one-to-many relationship is faster. When you use this relationship, you internally use a bidirectional filter of the other technique that I shown you before, and this has a performance impact. But that said, so far, the result is the same, right? So where is the problem? Now, if I use the technique that I shown you now, the technique that I shown you using the table in the middle with the two relationships, or the technique that we used at the beginning by using DAX, in all these cases, we have a problem. We should never use the implicit measure. The implicit measure is something on which we have no control. The only difference at the moment is that the budget amount measure that we have here. Let's see where is the budget amount measure here. Come on. Oh, this one. So the budget amount measure, I just want to change this. It should be in the budget table, okay? The budget amount measure that we see here is just a calculate sum. But because I have a calculate, I could write something here, okay? So let's remove calculate. It's just a sum, right? But I can write an if statement. I can write something. And this is necessary as soon as the user create a report that does not match the granularity. What does it mean? Imagine the user includes the color. What happens if I drill down, controls a color? Well, we don't have the budget by color. So the budget is the same budget of the brand. Now, if you look at this report, you may say, Marco, come on. We understand the problem, right? We know that the budget is by brand. If you go by color, it doesn't work. Okay. But again, it's just that you assume that you know the model, you know all the stuff. If someone creates a report by using the color only, without the brand, what happens? You see numbers. Now, these numbers are so big that you might suspect there is something strange. But other times, if you have no idea about what the right number should be, well, you might assume that this number is correct, which is not. What is the number we're looking at? Well, this number is the sum of all the brands that have at least one product black. This is the sum of all the brands that have at least one product azure. Because a few brands have azure product, this number is smaller. But you understand, it's still wrong. Because this number computes the same brand multiple times in different colors. What is the right thing to do in this case? Well, let's go back to this visualization, which is more understandable. I want to see the number here, the bold one. I want to see blank here. I don't want to see any number here. This number should disappear. Because this number is projecting a value at a level of granularity, which is not compatible with the relationship we have. Our relationship connects the brand. Everything that is below the brand should disappear. We don't have a budget for that, right? And how can I do that? Well, there is a way to do that, which I'm going to show you without explaining the concept behind. But the idea is the following. Let's say that we have two measures. Number of products, which is just the number of rows of the product table. And I show this number here. Then I create another measure, which is the number of products at the budget granularity, which is a calculate of the number of products where I remove the filter from the product and I apply the filter on the column that defines the granularity, which is the brand column of the product table. Okay, this technique, remove filter table values column, is the technique that we use to, let's say, retrieve the cardinality that we have for a particular relationship. So at this point, when you compare these two numbers, let me show these two numbers, you should detect one thing. When the two numbers are the same, we can compare the numbers. When the two numbers are different, we cannot. Simple as that. So if we have a measure, we can write if the number of products is equal to the number of products at the budget granularity, then show this value, otherwise blank. Here we go. And now we have the right number. That's the reason why we don't want to use the implicit measure, right? So the implicit measure is dangerous because it would show a number anyway, also in cases where it is not compatible. Whereas if we do this job, and of course, I should do this job also for the customer. So let me complete this in a moment. So number of customer is equal to count rows of the customer table, and number of customers at the budget granularity is equal to the same calculate. So you see that, of course, I remember this, but it's a question of once you understand these concepts, it's just that I always apply the same pattern. I don't think too much about what I'm doing. I just have to use the right column here. But at the end, I have these two measures, and I apply to my budget amount an end condition that says the number of customers is equal to the number of customers at the budget granularity. Okay. And now I can remove these numbers, the product, but this is what I want. In case I use just the color, everything is blank, but the total is correct. I can show the total. I can compare the total. I cannot compare the value at an intermediate step because it is not compatible. Now, what I'm saying is, and this is very important, if you use a many-to-many cardinality relationship, or you use a propagation of the filter using the bidirectional filter with the intermediate table that we have seen before, or you use the propagation of the filter by using three tags of in that we have seen at the beginning. In all these cases, you should protect the calculation that you obtain with a similar technique, because this is the only way to expose a measure that will work in a meaningful way in any report. And this is to me, the minimum you should do every time. Otherwise, don't use those relationships, because you are at risk of showing some data that doesn't make any sense. And I see too often these relationships without any protection. Now, at that point, and just as a bonus, we could say, instead of showing blank, can we show a number here? I mean, why don't we allocate this number by using some ratio? I mean, if I use the sales in the previous year and I allocate the number, why not? Well, we can do that, right? We can create an allocation percentage, which is equal to a ratio between the sales in 1 year and the sales in the same year at the budget granularity. The budget granularity is the same technique I described before. So I remove the filter from the product and I apply the filter to the brand. I remove the filter from the customer and I apply the filter to the country. I'm going fast now because of the time, but because to me this is a bonus. So it's something you can find a longer description in the article that I will show you at the end. So this is a percentage that I can show. So basically you see that, well, this is telling me, well, this is a percentage I could use to allocate this number here. Let's do that. So I can go here and I can say, well, if I'm here, I want to show the sum of the budget. Otherwise, I want to let's say, multiply the allocation percentage by the sum of the budget. Now, this is not the best calculation possible. Let me show you why. The article will explain this better, but I just want to show you that there is a small difference if I use two different techniques. So let's remove the allocation percentage. So you see the two numbers now are identical at the moment. But the right calculation should do this allocation for each combination of country and brand, because otherwise in different report you could have different numbers. Long story short, you should write something like sum x cross join distinct of product brand and distinct of country region. But we enter into the area of what is the right way to allocate, to dynamically allocate the budget, which was not the real topic. I just wanted to show you this because it's something we could do. We also need a calculate here. And also, to be honest, there should be also key filters here. But that's, again, it's something that because I want to show you the complete syntax. Now, if you look at the difference, the two numbers are not the same. The number I computed now, it is guaranteed to be consistent. So you create this measure in different report with different slice and dice, the number match. If you use this number, depending on the filter that you do, depending on the aggregation that you do, you might find different rounding. So the number is not completely wrong, but you could find reports that don't match. And accountant don't like that. So probably you want to use a more stable report. Look at the article about my last solution if you're interested into the allocation. But again, my goal was mainly to focus on the data modeling issue and on the importance of detecting whether the value that you are showing is compatible with the granularity of the data that you have. If yes, show the data, otherwise hide the data. That is the more important message that I wanted to transmit today. Questions?
That makes perfect sense. Yeah, I don't know. Have you got time for just like a couple of minutes for well, there's one question at least, which is I don't know if you can see it on the marker. There's a question from Emma saying, how would you handle a situation when you have to show both the brand and product table by color and attributes from the same dimension table? So would you possibly create another inactive relationship perhaps?
No. So let me repeat the question. So if I have a new brand here that doesn't exist in product, I have two options. One is that we use the solution that I showed you with the brands table. At that point, you show the brands table, you hide the brand column in the product table, and it works. Okay, it works. You don't have to do anything else. Of course, you still have to, let's say, protect, if you want, the measure, but technically you will see all the brands this way. It's just inconvenient for the end user because they had the brand column in a different table. That's the only price to pay you have. But that doesn't require additional effort in terms of data preparation. The alternative is that you create a product for the new brands. You create a dummy product for the new brands. How? Not in DAX. You have to use Power Query, SQL, whatever. I mean, you have to work on the part that prepare the data before you import the product table. You don't have a way to add a row to the product table in DAX. You cannot. That's
Yeah. Thank you. Yeah.
Okay. No, I understand. Okay. So
yeah.
now I understand the point.
To clarify, when she wants to show budget for more than one.
Okay. So the question is different. So I just rephrase the question. Let's say that we had here brand and color. Okay. Imagine you have the definition of the budget is by using two columns that exist in the product table. What you should do at that point, you should create a single hidden column. The user should not see that column, combining the two values, because when you create a relationship, you have to use one column. My suggestion, when you do that, you could combine the columns as you want, But there is I show you very quickly. Let's assume for a moment that we want to do that in this budget table by concatenating the country and the brand. It doesn't make sense, but just to show an example, you could create a calculate column saying, okay, my new key is equal to, let's say, country region. So this is the wrong way to do that, right? Let me explain you why. If you do this, you concatenate that as a string. Well, there are cases, hypothetically, where you have A, B, and then C, and then you have A and B, C, and they produce the same result, which is wrong. So usually you put a separator here, like, for example, this one. But again, it's okay. It works. But there is a specific function to do that, which is combine values, where you can specify what is the delimiter. Usually you use a strange character, like, for example, the pipe, something that will never appear in the values. And then you provide the list of the columns. Why I suggest you use this technique? Because this technique, in case you use direct query, it produces a much better query plan. So when you use a calculate column that is materialized, when you import the data, it is like a concatenation of the strings, but it saves you from the possible mistake of forgetting, I don't know, the ampersand or doing some stupid mistake in the expression. But when you use direct query for any reason, then this translates into a join that uses the two columns. So it produces a much better SQL statement in case you use direct query. And that's the reason why we use combined values in a calculate column when we have to solve this problem. We always want to have a single column to identify the possible relationship. So you need the same technique that we have seen before, but you need a column that is unique to create the relationship.
Okay, I think we are going to have to leave it there. Thank you.
Yep.
Yeah, thank you so much, Marco. That was fantastic. Yep. Absolutely amazing. I certainly got something out of it. So yeah, thank you everybody for your great participation. And yeah, was there anything you wanted to finish off with, Marco?
No, I just want to thank you for listening, and I will provide the slides and the demo file to Danielle, so she will provide you a link probably to download it, and so you can play by yourself with the link to the article that I shown you before. Oh, the link is already in the chat window, I see. You can find also in that article, there is probably something more in the article. I just wanted to focus on the data modeling part, but the article is more specific about the budgeting part.
Cool. Did you say you're going to actually send us a model as well?
I can send you the file that I use, so that because you know, every time the demo could be slightly different. So I will find exactly the file that I use. Yes.
Yeah, that would be great if that's
of course
an option. Yeah, thank you so much. And importantly, when are you coming back to Australia?
I don't know. Hopefully next year.
Yeah,
it depends on a number of factors. I still don't know. Probably I hope to know that by December, but we will see. We will see. Hopefully yes, but I don't know.
All right.
If it is not next year, it will be in 2026, but hopefully next year. I just don't know.
I look forward to that. All right. Thank you so much, everybody. And yeah, I'll see you again soon.